our study of geometry, we're going to assume that we know very, very little. Essentially, at this point, we're going to assume that we know two things. We know what a point is, and we kind of know what a line is. We can think of a point as a small dot on a piece of paper, but really it's just a location. And then a line is something that has length but no width. And essentially that's all we're going to assume we know at this point. Before we can dive into our study of geometry, we're going to talk a little bit about sets. A set is just a collection of objects. It can be any type of objects. Elements are these objects that are in the sets. They're the members of the sets. So a set is a collection of objects, and those objects are called elements. Next, we'll do a little bit of notation for sets. Let's let S be the set of all positive even numbers, so 2, 4, 6, 8, 10, 12, etc. We know that 6 is in this set, so we write this symbol right here, which is read as is contained in. So this is read as 6 is contained in S. So this means that 6 is actually an element of our set. Drawing a line through it means not. So in this case, 3 is not contained in S, so 3 is not an element of S. So this is our symbol of just meaning that the thing on the left is actually an element of the set. The first thing we'll look at with sets is called the union. And if I have two sets, A and B, then this is how we denote the union. A, this symbol that kind of looks like a U, and then B. The union is the set of all elements belonging to either A, or to B, or to both. So let's look at an example. We have a set A, which consists of the elements 1, 2, 3, 4, 5, and a set B consisting of 2, 4, 6, 8, 10. Then A union B is the elements 1, 2, 3, 4, 5, 6, 8, 10, since all of these elements belong to either A, or to B, or to both. The next set operation we want to look at is known as the intersection. And this is how it's denoted. It kind of just looks like the upside down union symbol. And the intersection is the set of elements belonging to both A and B. It's what they have in common. So we'll once again consider the same sets that we had before. A is the numbers 1 through 5, and B 2, 4, 6, 8, 10. Then A intersect B is just the set 2 and 4, since 2 and 4 are the only things that are in both A and in B. Next, we'll consider a very special set known as the empty set. And it's denoted by this, with a 0 with a line through it. And the empty set is a set that actually doesn't contain any elements, hence the name. There's actually nothing inside of it. To see how this is used, let's consider these two sets. A is 1, 3, 5, 7, 9. B is 2, 4, 6, 8, 10. When I try to take the intersection, there's nothing that these two sets have in common, so it would be the empty set. There's nothing that they have in common, so their intersection would contain no elements. The next idea that we'll talk about in relation to sets is that of a subset. We say A is a subset of B if all of the elements in A are also in B. So the idea of a subset is that A is kind of a smaller set inside of B. And this is how it's denoted. A with this symbol right here, B, or another one that doesn't have the line, the bar underneath it, for proper subsets. So a proper subset just means that A is not equal to B. The difference between these two symbols is very much the same as the difference between less than and equal to, or less than. The bar underneath just indicates that they could possibly be equal. So as some examples, here's three sets that I have. A is 0, 1, 2, 3, B 0, 1, 2, 3, 4, and C 1, 2, 3, 4, 5, 6. We can see that A is a subset of B. In fact, it's a proper subset since they're not equal, but the idea being that everything that's in A is also in B. We can also see that B is not a subset of C. In particular, B has the element 0, but 0 is not in C, so that would not be a subset. One more thing with sets before we get back to geometry is the idea of the universal set, also known as the universe. The universal set is just the set of all of the elements under consideration. It's everything that we're actually considering at that time. And we assume this is non-empty, so we assume there's actually something in there. In the purposes of our studies, we're considering geometry, so we're going to let our universe be all of the points in the plane. which we denote by a script P. So this is going to be our universe. What we're considering is all of the possible points in our plane. As I said before, we're only assuming that we know what a point and a line is, and we're actually going to build geometry from the ground up. So let's start with our basic axioms, things we're going to assume. Axiom 0, so our most basic thing, is we're going to assume a line is a proper subset of the universal set. So what that means is our universe consists of more than just a line. It has to have, at minimum, an extra point in it. Axiom 1, each line is a set of points having at least 2 elements. Essentially, that means we need at minimum 2 points to define a line. A line can't just be 1 point. And then axiom 2, there exist 2 points and each 2 points belongs to some line. So what this says is there's a minimum of 2 points. There could be more, but at least 2 points. And for every 2 points, I can draw a line between them. So there's no 2 points where there's no line between them. And this is where we're going to start. We're going to assume at this point that we know nothing but these 3 things, and we're going to look at what kind of geometries we can build. And these are called our axioms of alignment.